So let's have a look at first 5 questions of paper number 2, right? Now, first question is going to be a rotational motion question. Now, under no slip condition, when this starts to rotate, if you consider point at P here, the velocity at this point is going to be V, here it's going to be V, and here it's going to be twice the velocity, and at this point it's going to be at 0, right? So if I just plot the graph, it's going to be a slope as this, right? Maximum of 2V, right? Now this is when it is traveling in a straight path. Now when this used to travel in an inclined path, you should understand the loss in potential energy is converted to its kinetic energy. So gradually the velocity of this particle starts to increase, right? So the same velocities now, if it start to rotate, along here there's going to be V, and after reaching here it's going to be 2V, back again V, and then 0, right? But during this phase, you're going to have a different velocity, and during this phase, you're going to have a different velocity. And you should understand the velocity is increasing gradually, right? So what's going to actually happen? It takes a shorter time to complete one rotation, right? Because of the increase in velocity. So if I just put the graph, the maximum value for P used to increase with time, and the time lap for a complete rotation is going to be minimized. So it's going to be a graph like this. A bigger time, and then a slight increase in its maximum value. Now you should understand that time duration is going to reduce, and then another velocity. You should understand that time duration is reducing gradually, right? So that's for the answer number 1. Now, if you consider the question number 2, right? Now, as I have already said, without wasting time on conservation of kinetic energy, we can easily obtain the velocities after collision, right? So when an object used to move at a velocity, first of all it's colliding with him, and then with this fellow, and then with this, right? Now you should understand, just take it as a theory, okay? Now when there are two identical masses, and if one is at rest, if the other moves towards the other, what's going to actually happen is they are just going to transfer the velocity. Now he's going to be at rest, and he starts to move in the forward direction. Now it's something like an example in a relay. First of all, there's a player. You're going to have 4 players. One used to complete a rotation, a particular path, like 100 meter, let's say, and he used to pass the baton to the other fellow, right? So he's going to be at rest, and the other person who gets the baton used to move, right? So similar to that, the velocity at here is transferred to him, and he's going to be at rest. Velocity at here is transferred to him, and he's going to be at rest, right? Now you should understand this object starts to move with the velocity v, and he is at rest. Let's say after collision, both of them move towards the right with velocities v1 and v2. Now without wasting time on kinetic energy, we can apply a new equation. That's the subtraction of these two, v2 minus v1. Now make sure that only when the kinetic energy is conserved, you can use this equation. v2 minus v1 is supposed to be equal to v minus 0, right? Now this is derived from max, okay? It's going to be E times, now when it's conservation of energy, you're going to have ES1. From here, we're going to have an expression, that's expression number 1. And when I apply conservation of momentum, I'm going to have mv is equal to mv1 plus 2mv2. From here, right? So by adding this expression, we can get values for v1 and v2. So when I add them, so these are going to be our answer. Okay, so now let's have a look at question number 3. Now if you look at in here, the object is floating inside a liquid of density d3, right? So if you understand, the entire volume of this object is going to be 4 by 3 pi r2 cube times d3. Now this is going to be the upthrust which is exerted on him, right? and this upthrust is equal to the weight of this object, right? Now this is going to be the upthrust, right? Now if you understand what's going to be the mass of this object, it's going to be 4 by 3 pi. Now if you understand d2 is present inside a radius of r1, so r1 cube times d2g plus 4 by 3 pi. Now if you understand the volume of the liquid present in here is going to be the subtraction of this entire volume of r2 cube minus the volume of r1 cube. So 4 by 3 pi r2 cube minus r1 cube, right? So this is going to be the weight. Now if you understand these two expressions are going to be same, so if you understand 4 by 3 pi, g is going to get cancelled off. So from here we're going to get d3 r2 cube, which is equal to d2 r1 cube plus d1 r2 cube minus r1 cube, right? So if I obtain this to the other side, we'll be getting d3 r2 cube plus d1 r1 cube, which is equal to d2 r1 cube plus d1 r2 cube as our answer. So this is the answer for the question number 3. So now let's have a look at question number 4. Now in here, now in this particular year, they just give all for this. The main reason is within a tank, you can't observe light patch such as this, okay? Now you should have far amount of water. Now maybe in an ocean is fine, okay? That's why they just give all. So if we look at question number 4, initially light dot is placed at here, right? So the ray is just going to move towards the water surface, and at this point you're going to have your critical angle, so that's going to be the radius. So if I get an expression for this, r over L plus D is supposed to be equal to tan C. So from here R is equal to L plus D tan C, right? Then if I just came to this expression, x divided by L is equal to tan C. From here x is supposed to be equal to L times of tan C. So if I subtract both of these expression, I will be getting r minus x is equal to d tan C. So x is supposed to be equal to r minus d tan C. That means there's a reduction in the radius. So let's come to question number 5. Now, initially there's going to be some amount of oil in a vessel which is floating in water, right? Then what they have actually done here is they have gradually removed some mass of oil and entered equal volume of water, right? So if you understand the maximum point, it's the water level is going to be almost at the brim of the vessel, right? Now without writing any expression, as this is an MCQ, we can write, now you should understand whatever force, this height is proportional to this. So initial force applied is capital M plus simple m. Simple M is the mass of oil, is proportional to H1. And in the next case, capital M plus simple m was initially present. Now we have removed some mass of oil, right? And we have added equal volume of water. So added volume of water is going to be rho WV, and removed mass is going to be rho naught V. And this proportional to H naught, right? So what I can actually do here is I can subtract both of these expression, right? So from here, right now, no need of G also, okay? It's also a constant, right? So if I subtract both of them from here to here, I would get H naught minus H1 proportional to V times of rho W minus rho naught, right? This is our expression number 1, right? Now still we have a proportionality, so we should divide by an expression. So if I divide with the expression number 2, if I divide them, I would get h0 minus h1 over h1 is supposed to be equal to v times of capital M plus simple m. Now the expression they are expecting from us is v over v naught. So I can just cross multiply them. Capital M plus simple m, rho w minus rho naught, h naught minus h1 over h1, which is supposed to be equal to v. Now what I can do is I can divide both sides by v naught. V naught, I'm dividing both sides by v naught. Right? And you should understand rho naught, density of oil, is equal to mass of oil divided by the volume of oil. Right? So from here we can get an answer for v naught as m over rho naught. So from here we would get an answer so this would be our answer.